I'm Anil Kumar. In this particular video, I'll discuss how to apply chain rule and find derivative of composite functions. We have 4 examples that provides you with a variety which you need to understand and do well in your test on this particular topic. The very first question here is, find derivative and express answers in simplified form. So we have 4 of these questions. Now normally you don't have to simplify your solutions, but that could be a condition at times. In my videos I will simplify 1 or 2 of them, but you should learn how to simplify especially the radical derivatives and practice. Question number 2 here is, if u equals to x squared, v equals to 1 over u plus 1 and w equals to square root of v, find dw dx. So we have linked u, v and w, formed a composite function w in terms of x, and you need to find its derivative. Then we have a very fundamental basic question here which says, if h is differentiable function, find following derivatives. So the first derivative is of function h of x to the power of 5. The other one is g of x equals to h as a function of x to the power of 5, right? The last question here is, a given differentiable function h, which is a composition of g and f functions, right? Sometimes we write this also as g of f of x, right? Use information below to evaluate h of minus 1 and h prime of minus 1. Well, I'll take this question. You may not be able to see the last line properly, which is kind of like this. And then we'll work on it. You can pause the video, copy these questions, and then look into my solutions. The basic concept which we are going to apply here is something like this. Let me explain with respect to this question here. We are given y equals to something to the power of 4. We can write this something as u, for example, another function. U as a function of x could be written as x squared minus 3 over x squared plus 3, correct? In that case, you could write y as a function of u, right? U to the power of 4. Now, you can see that we have formed a function which is composition of 2 functions, which is like this, right? It's easier to find derivative of y, which is with respect to u, which is 4u cubed, correct? Times, if we do that times du dx, we get dy dx. So basically, the chain rule works like this. To find dy dx, we'll find du dx, or we can say from here, we'll find dy du, correct, which is 4u cubed. Multiply that by du dx, which you can find using quotient rule, right? When you multiply, you get your derivative. So that's how you could do it. Easy, right? So we'll explore this, and that question here simply says that this could be extended to 3 functions, 4 functions. There is no limit to it, right? So now let's begin solving them. I hope the concept is clear. We'll apply this concept and solve these questions one by one. Now the very first question here is a relatively simple question. What we're talking about is a function which is y equals to x cubed plus x squared minus 2. So that is a function in x to the power of 3 over 4. Now let me once again explain you the chain rule. We can say that the inside function here is u. Let's say u is a function of x, and it's written as x cubed plus x squared minus 2. So we can differentiate this with respect to x and write du dx as equal to 3x squared plus 2x. Perfect. Now, I can write the function y in terms of u. I could write this as y equals to u to the power of 3 over 4 and apply the power rule. So I say dy du, since y is now a function of u, 3 over 4 u to the power of 3 over 4 minus 1, which is minus 1 over 4. Correct? Now, that means I could write the composition, which is, we really want to find what dy dx is, as product of these two, which is dy du times du dx. So when I multiply these two, which are, let's say this is one and this is the other one, and then I replace u with what we started with, we get our answer. You get the idea, right? So the whole thing is derivative of derivative of y with respect to x, which is this, is equal to, that is the derivative of just taking a power rule. Do you see that? Power rule with the same function times derivative of inside function. Do you get an idea? Right? So that is what we can do as an alternative, and that is called the chain rule. Perfect. So let me apply this here directly. So we can also write this as dy dx is equal to derivative of all this, applying the power rule first, which is 3 over 4 within brackets x cubed plus x squared minus 2 to the power of 3 by 4 minus 1, which gives us minus 1 over 4 times derivative of inside function, which is x cubed plus x squared minus 2, the function u. Do you see that? And now we could write this as, now that is negative power, so we have to bring it down, right? So we write 3 on the top, and we could write this as 4 times x cubed plus x squared minus 2 to the power of 1 over 4, right? Fourth root. And the derivative of this function is 3x squared plus 2x. Now we can write it in the final form, which is in the numerator we have 3 times 3x squared plus 2x, and in the denominator we have 4 times 4th root of x cubed plus x squared minus 2. Do you get it? So that is how we are going to find derivative of all composite functions, correct? So you got an idea. So let me, based on this, write down the formula for you. So if you're trying to find the derivative of a function f of x with respect to x, in that case, I mean, it's a composite function. Actually, I should have written f of g of x. I want to write capital F, but anyway. So if you want to write derivative of f of g of x, right, in that case, let me rewrite. If you want to find derivative of f of g of x, do you see that? So that is that u function, correct? Then you could write this as derivative of the function f of g of x times derivative of inside function, that is u for us, times this function. Do you get an idea, right? So I have explained the rule now. In the coming videos, I'm not going to explain this part, but I'll do exactly as I did here, right? I hope that makes sense to you. Okay, so here is another one where we have kind of power rule and a chain rule combination. So what we are given here is function y equals to x squared minus 3 over x squared plus 3 all to the power of 4. So if I differentiate with respect to x, I'll apply the power rule first, which is 4 times x square minus 3 over x square plus 3 to the power of 4 minus 1, which is cube, times it with derivative of inside function, right? So derivative of outside times derivative of inside. Now inside function is x square minus 3 over x square plus 3, right? So power has been taken care of with the power rule. Now we are multiplying with the derivative of inside function. Perfect. So what we get here is 4 times x square minus 3 over x square plus 3 cube. And this derivative, we can apply the quotient rule. So we get x square plus 3 whole square in the denominator. Derivative of numerator is 2x. So 2x times x square plus 3, take away. Derivative of denominator is also 2x times x square minus 3. Got it? Now this could be simplified. So we have x square minus 3 over x square plus 3 whole cube. And here we can take away something common, which is 2x. 2x is common. So we'll take 2x common. And we are left with, within bracket, let me write, x square plus 3 minus x square, and that also becomes plus 3, minus minus, over x square plus 3 whole square. Okay? So we can take it to the right side and write it in a simpler form. You see x square plus 3 in the denominator, power 3 and 2 becomes power 5, correct? So we can write this as dy dx as equal to 2x is common, 2 times 4 becomes 8. So we have 8x times x square minus 3 whole cube. And this expression x square cancel, and we have 3 plus 3 as 6, it gets multiplied by 6. And the denominator here is x square plus 3 to the power of 3 plus 2, which is 5. Right? You could further multiply these two, and you may write this as 48x x square minus 3 whole cube over x square plus 3 to the power of 5. So that becomes your answer. Do you see that? Okay. So that is how you could do such questions. Now let's take the next one here, which is kind of tricky. Pause your video, answer the question, apply the rules, and then check with my solution. The question here is, find derivative of f of x, which is equal to square root of x plus square root of x plus square root of x. So we can apply the chain rule here. We could see this function as, you could also write this function as, so this is the top square root which we are trying to work out. We say x plus, so let me write at first stage only like this, square root of x plus square root of x, right? And everything to the power of half, right? So you can apply the power rule, then you get this minus half and half here, and then find derivative of the inside function. You get an idea, right? And then you can continue with that, correct? So let me show you how to find derivative of such functions, right? So let me first write this function as equal to. So we'll write like this. You could actually write these terms also as a power of half, right? Or you need not. You may just straight away write the function as such. Okay, either way, let's do it like original function. So we have this inside, right? So the idea here is to find derivative of x, or derivative of f of x with respect to x. Now, we'll start with the outside function, which I've written like this here. So it is half of everything here, which is x plus square root of x plus square root of x. All this to the power of minus half. Correct. So we applied the power rule first. And then it is derivative of inside function. Inside function now is x plus all this, right? So let me write in the square root form. Do you see that? So derivative of outside function times derivative of what remains inside. Correct? Now this could be written as, now this is negative, so that all this comes in the denominator. So we have 2 times square root of original function, which is x plus, now let's see the derivative of this. Now derivative of x is 1 plus derivative of this is half over, so we'll write now 1 over, you understand, 2, and the whole thing, which is x plus square root of x. Does it make sense to you, right? The whole thing as we wrote there. So we got the derivative of these two times the derivative of inside function. Do you see that? So we got derivative of 1, x as 1, but here we have to multiply by the derivative of that function. I should not have closed the bracket here. I'm sorry. Because now we have to multiply this part because that is not complete here. So derivative of this times derivative of inside function, which is x plus square root of x. You get an idea. Inside function, correct? Now I am going to close the bracket because there too x was 1. We're trying to figure out derivative of this, which is half to the power of all this to the power of minus 1 times derivative of inside function. You get an idea, right? Okay. So that is 1 over 2 square root of x plus square root of x plus square root of x, right? And here we have 1 plus all this, which is 1 over that function, 2 square root of x plus square root of x, times derivative of this function is what? Derivative of this function is x derivative is 1, and square root x derivative is 1 over 2 square root x. You get an idea. So that becomes your result. I'd like you to go through it. Very important. See, at this stage, that is the composite function. Perfect. So you applied the rule twice here to find the result. Correct? So let's go. So I'm not solving or simplifying it further. That's it for me. And we'll move forward. So we have another good example on chain rule. So we have f of x equals to cube root of all this. Correct? So we could write this as derivative of this function is, so when it is cube root, okay, so let me rewrite this first. You could rewrite this as x squared minus square root of x to the power of 1 over 3, right? So when you take derivative, it becomes 1 over 3 times all this, that is inside part, right? Which is x squared minus square root of x to the power of 1 over 3 minus 1, which is minus 2 over 3. Does it make sense to you? Times derivative of inside function, which is d dx of inside function is x squared minus square root of x. Perfect? That's the chain rule. Now we'll rewrite this as 1 over 2 times, and that is square cube root, right? So cube root of x squared minus square root of x square. So we could write here. Is it okay? Times derivative of this, which is 2x minus derivative of this is 1 over 2 square root of x. So that is your answer. Do you see that? So our answer here is, we could write this as 2x. Well, that is a good way of writing also. Good enough. Some of you can just, write like this also. Cross multiply. Then take 2 common. We could do that. So 2x times 2 square root x minus 1 divided by, we get 2, cube root of x square minus square root x whole square, right? And then this part comes in the denominator. So we had this times 1 over 2 square root x. Do you see that? 1 over 2 square root x. So you could have written something like this, and finally, we could write our answer as, let me write here. So 2x times this is 4x square root x minus 1 over 2 times 2 is 4 square root x times cube root of x square minus square root x whole square. So all this whole square. Perfect. So that is how you could find the derivatives of composite functions using chain rule. Now let's get to some very concept level fundamental questions on chain rule. We are given u as x square, v as 1 over u plus 1, w as square root of v. We need to find dw dx, right? So you can clearly see u is a function of x and du dx is going to be 2x. Here we have v, which is a function of u, 1 u plus 1, and dv du will be. Now you could use, I think, product rule. You could write this as u plus 1 to the power of minus 1. It becomes easier, right? So this is minus 1 over u plus 1 whole square, correct? Either way, you could use quotient rule also, get it. And w is given as square root of v, so we have dw dv as 1 over 2 square root of v, correct? What is dw dx? dw dx, because now you can see w is differentiable and is a function of u, v, and all this x, right? So it could be written as dw dv times dv du. So you go move inside. Du dx, product of all this, right? So which is 1 over 2 square root v times this, which is minus 1 over u plus 1 whole square times 2x, or minus 2x, 2 cancel, let me write minus x, over square root of v times u plus 1 whole square, right? So we are writing this derivative in terms of u and v and x. Okay. But I hope the concept is clear. That is the basic concept of chain rule. Now we have few interesting questions. If h is differentiable function, find the following derivatives. So a composite function f of x is given to you as h of x to the power of 5. Now how will you write the derivative of this function? So that's very simple. So the derivative of this function is, first apply the power rule, which is 5 times whatever you have to the power of 4. So first apply the power rule and then multiply by the derivative of inside function. Do you see that? So that becomes the answer for the given question. Correct? The next question here is similar kind. However, this time we have h as a function of x to the power of 5. So in this particular case, we can write this derivative as h prime of x to the power of 5, and then we apply the derivative of inside function. So we have d dx of x to the power of 5. So that could be written as derivative of the function times 5x to the power of 4, right? Rearrange and you can write your answer as 5x to the power of 4 times derivative of the given function. Correct? So that is by definition, and it's a very important question from test point of view. The last question here is kind of interesting. We are given a lot of information in the table, and from there we are going to find the derivative. So the question here is, given differentiable function h equals to composite function g of f of x, use information below to evaluate h of minus 1. So we need to find what is h of minus 1, and we also need to find what is the derivative of this function, composite function, at minus 1. Correct? So let's do it one by one. So the first one here is, we know that h is g of f of x. Now since we want h of minus 1, we'll substitute minus 1. So we have g of f of minus 1. Perfect. Now what is f of minus 1? Means value of function f at minus 1. So we're looking for this. So f of minus 1 is 1, right? So I could write this as g of 1, correct? Now we have to look for the value of function g when x is 1. So that is this. When x is 1, what is g? It is minus 4, right? So we write this as minus 4. So the value is minus 4. Correct? Now the second one here is kind of a composite function. So what we are given here is h equals to g of f of x, correct? So the derivative of this function at, we want this at minus 1, will be derivative of the whole function at minus 1 times derivative of inside function at minus 1. You get an idea, right? That is what it is. So now we'll write down, so what is derivative of, what is f of minus 1? That basically means f of minus 1 we know is 1, so I'll write here 1. And what is this derivative at minus 1? So at minus 1 the derivative is minus 5. So we'll multiply this by minus 5. Correct? Now what is the derivative of this function when x is 1? It is minus 7. So we could write this as minus 7 times minus 5, which gives us 35. So we get 35 as our answer for this part. So I'd like you to go through this once again. That is a very important question. Many times in multiple choice question, you get all this. And that too in tests like AP Calculus, IIT JEE, so it's a very important question. So I hope you understand and you enjoyed the way we worked out on chain rule. And feel free to write your comments, share my views. And if you like and subscribe, that'll be great. Thanks for watching and all the best.